In today's webinar, we are going to show you what are the latest technology available in the market in terms of paint removal or paint stripping. Some of you may call it paint cleaning. As you may know, it's undesired but yet unavoidable operation that every paint applicator needs to do. And for now, what we have available in the market is pretty much three basic methods: mechanical, we have the thermal method to remove the paint from the jigs, the toolings, and the rack, and we also can have the chemical stripping. All of these are on the market for quite a long time. All of them have a positive and negative aspect of it. And we are going to try to explain what is the pros and cons of the different technology and what is a better solution we can consider today. If we consider the mechanical method, it's a pretty basic and simple. It's a way to remove mechanically the paint from the surface with impact, grinding, sanding, hydrojet. All these names are referring to mechanical stripping. It's fast and easy to implement. Is also usually not high cost to implement. You have a blasting machine or thing like this. The downside of it is it's impossible to avoid the substrate damage. It cannot remove the paint from the tight geometry. It can dull the surface, making the paint more adherent later on. It's very slow and labor intensive. We have a heavy noise. It's not suitable for all the part reclamation, and the paint collection is very time-consuming process. If we look at the thermal method, this method is a little bit faster than the previous one. This has been developed because not everything was possible with mechanical. The thermal paint stripping method involved degradation of the organic coating with the extreme heat. So meaning extreme heat, this mean is also going to have an effect on the part. The common terms we use is pyrolysis, molten salt, fluidized bed, is all technology using extreme heat to break the coating. The biggest issue we can see with this one is it's weakening the metal. So we need to have like a heavy gauge material. It can become brittle. It can create fire hazard. It's very high energy consumption. We have also some high maintenance, and typically also the paint removal equipment has pretty short life. So it's a high investment for having this operation effective. After this, we also have seen on the market some chemical stripping. Chemical stripping started with a simple basic caustic product, but it can be also other type of solvent now. We can consider high vapor pressure solvent. We have a high alkaline hot product. We have also the heated concentrated acid, mainly for aluminum stripping or substrate that is not possible to use hot alkaline. What we see as the disadvantage of this technology is also typically limited to the substrate. So we have to take in consideration compatibility with the substrate. It generates a large amount of waste. It's very cheap product. It could be cheap product. Not all are cheap actually, but it could be cheap to buy, but it's going to require frequent makeup. It's going to have inconsistent performance. It's going to slow down with time. It can also have a health hazard. It can be a hazard for the people operating, for the environment, and for the operator on the maintenance. Typically, the strip rate are rapidly going to slow down. It can have a good performance at the beginning, but as a solution loads, the performance rapidly decrease. What we see also is every of this technology, they have direct cost, which is regardless of the method we are using, we have to find one or the other method. And to identify the associated costs is not always an easy task. What is always easy is to see the obvious. We can see the service fee if we outsource, we can see the consumable if we have something in a house, but it's represent maybe just a fraction of what is the real cost of paint removing. If we look at the direct cost, I call it here the tip of the iceberg. You can have a cost like the energy, the gas, the electricity, the media if you use blasting or thing like this. If you are using water, you have the direct water consumption. If you outsource, you have different cost structure, which is easier to see. You have like the service fee and the transportation, and you believe this is what cost me for this operation. The reality is you have also additional indirect costs, and these costs are not always obvious. Maybe they are not impacting the same department you are working in. Maybe it's requiring some more investigation, some more cooperation in between other departments to have a more global view. If we look at this additional cost, we need also to take in consideration the equipment depreciation if you have in-house stripping, the equipment maintenance, if you have a burn-off oven, if you have a water jet, if you have a blasting machine, you have the maintenance associated to the equipment. Sometimes also you need a secondary cleaning to remove the dirt, the debris, to have additional operation because you have a complex geometry. You have this also sometimes, even if you outsource, maybe you are going to receive back your tools and they are not going to be 100% clean. So it will force you to have additional operation when you receive. The repair and the replacement due to the damage, depending on the technology you use, the damage and the repair are going to be more or less needed, but it could be also from the outsourcing. You can have damage also during transportation. If you use a robotic line, it will have an impact on your painting, the pattern of your spray. So this is why you need to also to repair the geometry. This is additional cost. The production of the paint defect due to unclean jigs and racks. Since the rack is not perfectly clean, it can create a lot of defect. We are going to discuss a little bit deeper this topic later. The extra volume of the painting heads for the rotation also is going to be, in some case, a big investment. This is if you need to send to outsource or even in-house, if you have a slow process, maybe you need to have extra 1 set, 2 set, 3 set of tools to allow the production to flow, to run. Since you need also to consider the time to ship to the company for the outsource, the time to strip, and the time to get the rack back. There are also additional costs of that under the label. If you have in-house operation, you need to have maybe 1 person, 2 person to operate. If you have a burn-off, you have some hidden time, because the time the part are stripping in the burn-off, the operator can do something else, but maybe the something else is going to have the secondary cleaning. So this means probably you need to have worker to work like a 100% dedicated for this activity. It can generate a lot of waste. If you have even hydrojet is a high volume of water, it's going to have a high water consumption. Also, even if you have a burn off, to rinse, to remove the hash, and to make sure the parts are clean before to return to the production. This is going also to have an impact possibly on your yield of the production. If the contact are not clean, you will have deficiency. We'll also discuss deeper this detail a little bit later. We have some product limitation also if we have in-house, because if you select one process, probably you have limitation to one operation. Maybe you cannot handle everything in one, or you need to multiply the technology at your facility, which pose another issue because it's not always economical to do this way. and the paint overconsumption. This is many times not really considered, but it can increase your paint consumption if you have unclean jigs and rack, and we will also discuss a little bit deeper. So it's very essential to have a clear identification of all this strip related costs before you make selection. If you already have a technology in-house, if you are already outsourcing, or if you plan to renew your equipment, if you already have a old equipment you plan to replace, if we can make a global cost analysis and you identify all the area where you have a cost impacted, you can really compare the technology to see what makes the most sense for you and what would be the most economical and also the most efficient. So the process comparison could be also in association to several process on one side. Maybe you are using a burn-off oven, but the burn-off oven is not sufficient, and the secondary operation is media blasting. So we need to consider all of this. If you compare it to sustainable paint removal, you say, paint removal, what is exactly paint removal and what this technology are capable of? Many of you, they have in mind the old technology and the mechanical technology. If we compare to sustainable stripping, say maybe sustainable stripping is not really a good choice for me. But if you compare to mechanical, in some case, you can have from labor intensive to damaging the part to very seamless operation and safe of part metallurgy, and also in addition is going to be safer for the person, is going to be less tiring for the people to operate, which is going to be a benefit. If you compare it to the thermal, you have ash, dirt, rust, and debris, and you need to consider. If you consider sustainable stripping, the new technology available on the market can offer perfectly clean surface at the first pass. It keeps the substrate completely intact and free of damage. If you compare it to chemical, sometimes you have toxic hazardous product. It's difficult to clean. It's slow process. We can have a solution with a low VOC, low energy demand, long life to no dump, and you have a solution for a very long time, which is going to minimize also the waste. If you consider the positive impact that can have on your productivity, it can also offer a positive impact on your cost control. So if we consider the poor jig cleaning, that could have a significant impact on the reject rate. If you have some dirt and debris that can create some paint adhesion issue, unclean rack and hook can drag dust and dirt into the line. It can alter the geometry. It could lead to uneven film build and paint failure. It can alter substrate and lead to hanger rupture and subsequent line stoppage. The sand transfer, if you use like a sandblasting or fluidized bed, it can transfer a lot of sand also to your washer line, to your cleaner, which can create a major issue. If you consider the blasting and you use bead blasting, if you have a spring mounted jig, you can have some bead can stay stuck in the spring and can have a malfunction. The pool cleaning might require extra operation, which could significantly also negatively impact your production yield. Sustainable paint stripping can help to reduce the reject rate also in this application. If you consider the poor grounding, it's also another effect we are not desiring. If you have a poor cleaning and clean contact, poor grinding can create uneven coating thickness. Some area could just not receive paint at all. If you see in the photo on the right side here, you can really can see that typically this part has received no paint at all. So here is painted, is maybe not even, here you have no paint at all. So it is going to require an extra effort to repaint, or just wasting time and money. Poor grinding could lead also to extra operation to manually cover the missed area. It's also increasing the paint volume need, and poor grinding will decrease the corrosion resistance if the coating is not so good. So all this operation can be improved also with the sustainable stripping. Sustainable stripping can also help to optimize the coverage to support with a better gloss also for the paint. The paint curing can be optimized. The coating will subsequently be more robust. Only minimal touch-up will be needed, which is going to save also on labor. The productivity will increase, and all this point will be optimized. The damaged paint tooling support can lead also to poor rack and losing parts. You can have the part that is falling inside the preheat mud washer, maybe inside the painting booth itself, maybe inside the curing oven. This is going to result in a downtime, maintenance time. Moving loosened part can also result in severe damage to the equipment. Line stoppage become necessary. It's possible also you have a robotic line with a conveyorized system, and the robot is catching the part on the conveyor because of the geometry, and is going to make very severe damage on your line, especially if you are working on a large part design. The line stoppage become necessity, and it could be long time when the equipment is damaged. Is occurring also a lot of risk for the people to repair the damage, but also it's a high cost because you have no production during this time. So unavailable to of specific tooling could significantly delay the production, especially if you have a strategic part you need to produce in a short time. So sustainable paint stripping can help also to reduce this type of downtime. If you look at the paint consumption, I was referring to paint consumption earlier. Sustainable stripping can also help to minimize this. If we look like a simple basic geometry, like a metal chair, typically it's like a 6 decagram of paint per unit. But if you have unclean contact, it can rapidly go to 8 decagram per unit, which is 35% increase in extra consumption. So considering the volume of the paint you consume every year, if you have a 35% you can save on this paint volume, the paint typically is not the cheapest material you are buying for the operation. The hook coating weight also can very rapidly increase. And if you look on this graph, is if you clean every pass or every 2 or 3 or 5 pass, is going to have like a not too much paint on it. But if you strip, let's say every 2 cycle, if you take the example of 1 meter hook long, it can be rapidly build up to 4 kilo of paint just on one hook after 10 cycle, where it could be only a few grams of paint if you strip more frequently. This is an additional cost that can be reduced also by sustainable stripping. The extra paint accumulated on this jig will be 100% waste. It's not possible to reclaim. It's going to be a pure waste. If you look also for the aggressive technology, like a burn-off, you need to have like heavy gauge steel, otherwise you can have frequent rack rupture, which is going to be a bigger problem, especially if you work with the heavy part. Frequent replacement is going to be necessary. Second operation almost unavoidable, and the geometry, the realignment, the weld repair, the magnet replacement. Some jig also have magnet, and you need to you cannot do burn off, otherwise you will damage, or you have extra work to remove them. If you look at compared to the outsource, you have also high volume of jig for the rotation, because you need to have one set in the production, one set on the road, one set at the contractor for cleaning, and sometimes one set on the way back. So this is why it's also requiring very high volume. If you have expensive jig, because you have complex geometry, it could be quite expensive to multiply this. And in addition, you need to have a storage space and some area to store these parts. So sustainable paint removal can also help in this, because you can strip faster, have the jigs and the rack available rapidly, and can return quickly to the production. It's an evolved damage that necessitates replacement, and this is not something you're going to see with sustainable stripping. Also, even smaller tool and spring is just not possible with this technique. So this is something you need to address in a different way. Sustainable stripping has also the benefit to offer lower energy demand, because some products have a low specific heat. And it's not only lower specific heat, because if you use at the same temperature, it can consume less, but it can also have better performance to run at lower temperature. So you save on different area. You have less energy need and lower temperature, which can make significant savings. It can also offer waste minimization. This type of technology can offer long life solution. It's very easy to filter. You can remove. So in opposition to a standard technology, you can remove the paint quite rapidly, and you can filter, have a long life to no damage solution. Also, you say maybe it's difficult to implement. It's not so difficult to implement, because today what available also on the market is to have in-house stripping, that pre-assembled unit that can really come to your facility, be assembled rapidly, and can be implemented very fast. So you can have a unit ready to use in a short time, which also going to offer very simple and basic process controls. So it's also going to be easy to maintain, easy to control, to ensure that you are going to have a stable performance over the time. Just quick case study to show you what the capability of this. We can go for part, we can go for even larger part for the OEM, for the skid carrier cleaning. Skid carrier cleaning, you can have a semi-automatic line. You clean the entire part of it. You have very less waste, because you remove only the paint. You have a dry residue. You have the full process is operated in a short time, and then it can save a lot. If we consider like an extra jig, an extra tool, if you talk about a car plant, it could be up to 600,000 savings, just because you don't need to have the extra carrier, the extra bumper rack, or thing like this. If we consider other application for the tools, is also can prevent to have like a risk associated to the manutention and to the people handling the tools. So it's also suitable for the smallest tool with the spring, and you can have a fast stripping. This at the same time can increase also the stripping capacity. If you already have a hot alkaline on your site, maybe you can expect to have 60% capacity increase. And this technology can help also to minimize the labor. In this example here, we have reduced by 57% the cost, and also this represent like almost $3 per car, which is very significant. It's no damage to the separate, it's safe for the worker, and in addition to that, we save on energy about, like in this case, like $4,000 per month, which is also not a small number. In-house stripping could be also inline stripping if we strip fast enough. In this example, it was not possible to do inline because it was requiring 2 hours to clean this rack, and you see the quality on the left. That was after 2 hours stripping. And on the right side, you can see the E-coat plus the liquid paint was removed in 8 minutes. So 8 minutes can fit the line speed, and it was really a way to set up inline stripping, so you can strip every pass and you can have a high quality finish. And this is like conveyorized system, but it's also inline stripping. So you just have the hook entering to the tank, getting stripped, exiting the tank. At the same time, you have minimum waste, you filter the solution, you have a dry sludge, so minimum waste, and long life for the solution. You can use the same solution over and over for years before, and with the consistent performance. So this is something that has changed drastically in the market, and it's something we can offer today. Many people think of chemical stripping, yes, it's nasty, I don't want this on site. because it's toxic, because it's dangerous to work with, but technology has changed, and today we really have solution to offer that makes the life of the users a lot easier. So in summary, we can say the downside of it is like the poor cleaning can have many negative impact on painting operation and rapidly drive the cost up. To identify the cost, a full study should be done, and you can really have the magnitude of what is the stripping cost. The stripping cost is not always just a small operation or just a material cost, but it could be more than that. So to get an accurate cost view, it will sometimes require to investigate in an area, even to talk to department you are not used to work with, because probably they see an extra cost on their side, the cost which is not visible to you. But the good side of it is sustainable paint stripping can efficiently support the process optimization, can be easy to implement. The technology have evolved and strive toward the sustainability. So now you can offer low energy, low waste, rapid and efficient, and stable. Also predictable, which is very important when you run a business to be able to predict what would be the operation in 1 year, in 2 years from now. The change to superior solution can really be easy and simple with the system pre-assembled. It's ready to use. You just connect to your installation, power and drain, and it's ready to go. And it's no need to compromise anymore between the high performance and low running cost. This now offer high performance at also low running cost. If you do the comparison, almost 100% of the time, you will see it will make sense for you. So it's very new approach to the market, but it can really change also your approach to paint removal.